Hey y'all, it's me, Miss Starling, back again. I'm going over some notes about the constant of proportionality. This is for 7th grade math. And here we go. All right, so the constant of proportionality. If we're discussing two quantities that are proportional, the ratio between the quantities is equal or equivalent. For example, 7/8 is the same as 56/80 or 64ths. Not 80, nothing. 64ths. Okay, it should be a 6 and a 4. It's also saying that 1/2 is proportional to 3/6. Okay, these are two equivalent ratios. A proportion is two equal ratios, and we commonly write them as fractions. Okay, so it's one quantity to another. In this case, it says Mario travels 180 miles in 2.5 hours. That's a rate. 180 miles over 2.5 hours. As soon as you see that, we identify that as a rate. We need to write it down. If Mario travels at the same rate, how far can Mario travel in 5 hours? So we want the same rate, so we're writing an equal sign to show that they are the same, and we want him to go 5 hours. We don't know what goes here, so we're going to put an X there, okay? So in order to determine that, we must fill out this table to figure out, okay, well, if he goes 2.5 hours, he goes 180 miles. And if I go from 2.5 to 5, I'm doubling myself. I'm multiplying by 2, or I'm adding 2.5. Let's put that I'm adding 2.5 here, because the multiplication will be from top to bottom, and then from left to right, it'll be addition and subtraction. So let me get my white out, fix this real quick, and we'll write plus 2.5 plus 2.5 plus 2.5. Okay, and plus 2.5. All right, so from here, if I'm adding 2.5 each time, then down here I need to add 180 each time. So here I'm going to put plus 180, plus 180, plus 180, and so on. So 180 times 2 is 360, plus another 180 is 540. Did I do that math right? Plus another 180 is 720. And plus another 180 is 900. Okay? So now I want to extend my table. And I want to know how far he goes in 1 mile or 1 hour. So I'm going to take any of these rates. I'm going to take 360 and 5. And I'm going to divide. I'm going to find my constant of proportionality. This is X and this is Y. So I'm going to take 360 over 5 because the constant of proportionality is Y over X. And then I'm going to divide 360 divided by 5. So come to the side here, 360 divided by 5. 5 goes into 36 7 times. 35, 10, 72 miles per hour is my unit rate. Unit means how far they go after one thing has happened. So 360 miles is how far he goes in 5 hours. Let's answer that. 360 miles. Okay. And then how many miles does Mario travel in 1 hour? Guess what? We already explained that. In 1 hour, he goes 72 miles per hour because for every 360 miles, he's driven or he's gone 5 hours. And I could have put any ratio there. Okay, so I'm dividing the miles by the hours. Miles per hour is a rate. The constant of proportionality is the value of two proportional quantities, the value of the ratio of two proportional quantities. It's represented by the equation K equals Y divided by X, where Y represents the Y values in a table or graph, and X represents the X values in the table or graph. And it is most seen in Y equals KX. Okay? So, examine the table below. Describe the patterns that are true. So I'm going to take my Y and I'm going to divide by X and see what I get. So 12 divided by 1. This is 12 divided by 1. That equals 12. 24 divided by 2 is also 12. 36 divided by 3. 48 divided by 4. And 60 divided by 5. All equal 12. Okay? For every foot, there are 12 inches. 2 feet, there are 24 inches. 3 feet, there are 36 inches, and so on. So, letter A, how do you know that the number of feet is proportional to the number of inches? Well, the constant of proportionality stays the same. The constant proportionality stays the same. It stays constant. Hence, Y, feet and inches are proportional. Using X, the number of feet, how do you find Y, the number of inches? So Y equals, what am I doing to X to get Y? So from here to here, here to here, here to here, I am multiplying by 12. So this is 12x equals y. Y equals 12x. Okay. So now, going on to the next page, we've got some definitions here. Y is my dependent variable. K is my constant of proportionality. And X is my independent variable. He does what he wants to do. All right, apply your understanding of the constant of proportionality to the questions below. Number 5, while training for a marathon, Keith's watch reported how many calories he burned at each mile marker. The data is shown. So it shows that for 1 mile, he burns 117 calories. Is the number of calories proportional to the number of miles? Explain your thinking. So let's see what happens from here to here, and from here to here, and from here to here, and here to here. And let's see if it's consistent. So here we're adding 1 each time. And it looks like we're adding 117. Let's come to the side. 117 plus 117. 7 plus 7, hey, is 14. Carry the 1. That's 3. 234 plus another 117. 4 plus 7 is 11. Carry the 1. That's 5. And 351. So far, it's showing a pattern of 117 over and over. I'm back. So it looks as if this is a proportional relationship, because each time I'm going to add 117, and each time up here I'm going to add 1. 117 added, 1 added. So it says, is the number of calories proportional to the number of miles? Explain your thinking. So I'm going to write calories per mile. And then I've got 117 over 1 and 234 over 2, and those are both equal to 117. So yes, it's proportional. The ratios are equal. Ratios are equal. The next day, Keith ran 7.5 miles. How many calories did he burn? So I've got 7.5 miles, and then I want to know how many calories he burns. Well, it looks like for every mile he burns 117, so I need 7.5 times 117. 117 times 7.5. 5 times 7 is 35. 5 times 1 is 5 plus 3 is 8. 5 times 1 is 5. 7 times 7 is 49. I'm going to put a placeholder there. 7 times 1 is 7 plus 4 is 11. And then 7 times 1 is 7 plus 1 more is 8. Then I'm going to add these up. And I get 5, 7, carry the 1, 7, 8, 1 decimal place. So this is 877.5 calories in 7.5 miles. For letter C, what is a constant of proportionality? What am I multiplying my miles by to get my calories? 117. Okay, equals 117, which equals 117 divided by 1, or 234 divided by 2, or 468 divided by 4. Okay? Write an equation to explain the relationship between the number of miles and calories burned. So this is my x and this is my y. I am multiplying x by 117 to get y. So my equation is y equals 117x. Use the info below to determine the constant of proportionality in each situation. I've got 1.5 cups of oil to 6 cups of water, 4 cups of oil to 16 cups of water. I'm going to take my easy fraction, or my easy ratio there, and do y divided by x, which is 16 divided by 4. Here, all of these are whole numbers, so I could just do the first one. This will be 3 divided by 2. And over here, all of these are whole numbers, so I could do 36 divided by 3. So this is x and y. Oh yeah, and this is x and y. So 16 divided by 4 is 4. Constant proportionality here is 4. 3 divided by 2, 3 goes in, 2 goes out. 3 is divided by 2 is 1. 1 times 2 is 2. Bring down a 0. 2 and a 10 is 5. 1.5. And then here, 36 divided by 3 is 12. 12 is my constant proportionality here. Hey, I'm making a video. So this is 4, 4, 4, and 4. And this is 1.5, 1.5, 1.5, and 1.5. And then this is 12, 12, 12, 12. And as long as all the ratios are the same from here to here, here to here, and here to here, these are all proportional. Okay, obviously, because it tells us to find the constant proportionality. Moving on to the next part of your notes. I know this says homework, but this is what was given to you in class, the constant proportionality. This is more notes. I want to give y'all an ample amount of practice before I give you an assessment. All right, so this says a gym employee is paid monthly. After working for 3 months, he had earned $4,500. So that's a rate.
But 95 is here, but 95. Students, please walk out
I'll finish the rest in the next video.